Testing, testing. Sound is good. Alrighty. Oh, light. Hey. Let's settle in first. Welcome to the light stream. Metal Rogue Dev 0.2 prototype code. This is more like production code, but prototype code for the Rogue development. This is done on the Mac OS 10.0, 10.15 I think we're on at the moment. Doesn't matter, it'll change over time. I'll give you other problems. So, hello to you all. Let's switch the lights on. I'm stoked about this because if we do this bit, it's going to be game on. I think I might write the full game. We've broken the back of the Mac OS. And it's no longer asking us to it is asking us to program in a certain way, but it's not something we're doing. What I'm trying to say is, when you pick up a programming language, do you feel like you are asking your computer to do something, or do you feel like you're telling your computer to do something? When you program a computer, you tell it to do something. Whereas higher level languages tend to be ask the computer to do something, because you've got no idea what's happening under the hood. So you've got no idea what you're actually asking the computer to do. So I figured out all of that, thank God, at long last, and we are on light. And as we are about to find out, OpenGL is going to rear its head once again. Oh, didn't say that. The graphics card is going to rear its head one more time. Can't say OpenGL. I'm not on metal. We're on a metal thingy. All right. Crimes, don't get it confused. Don't confuse people. Metal and OpenGL. Oh, they're way different. No, they're not. Exactly goddamn same. Look, here's GLSL. This is the C code, which we've already done for the main program. And we can now follow this quite closely. And I've checked to make sure that I hadn't made a mistake with that object here. And this follows C compliance. All of that is what we've written. Have a look, there's all underscores. There's no Swift here. Yeah, underscores, underscore, underscore. All the underscores are in. Underscores mean I wrote it. Except in one place where they put underscores in where they shouldn't have done. That's with the matrices, and I didn't write those. I won't take credit for the matrix rubbish that was there. Right, now, lighting should be done in the fragment shader. I'll hold my hand up to this one. Please, 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 please do your lighting in the fragment shader. Me, I wanted something different, so I'm going to use the vertex shader. To hell with all that. I do not comply with modern thinking at all. I don't see the point. Modern thinking just tries to complicate things when all you have to do is tell a CPU to add two bloody numbers together. Because that's all it can do, by the way, a CPU. It can't do anything else but add two numbers together. And in this case, are 64-bit numbers, so they can be big numbers. There you go. That's all a CPU can do. When you realise that fact, all of these words mean nothing, really. But we are going to try. So we have our lighting position. We're up here on the uniforms. We have model matrix, view matrix, projection matrix. Model, view, projection. Oh. Right. Then we have light position. I've added colour in here because we had colour in location 1 and I took it out because it's not needed. We're going to be using textures instead. Yeah, textures has replaced colour there. But I'm keeping colour in as a constant, as a uniform, because it might be useful if a texture fails or whatever. That reminds me, I've got to split the vertex shader now, in case the texture fails. So after light position, we have a Vec3 light colour. So that's a var light colour. It's what? A Vec3, float 3. Or 3 floats make a Vec3. There you go. We'll keep it in SIMD3D, SIMD3, which means it can be spread across multiple GPU cores. There's hundreds of them, by the way. There's a lot in a GPU. Initial value will be float 3. The one that I normally use for daylight is 0.8, so that's what we'll use. How's about that? Because that's what we're going to set it to anyway. In fact, we won't need to set it because of that. We don't want to. What do we got next? A float shine damper. For damping the shininess of an object. And that's just a float. Now, what do we set it to? I have no idea. 1 is a safe number, so that's what we'll have. What should we have next? Reflectivity, another float. Oh, it's that word again, isn't it? TVT. I always have fun with this one. That's a float. Set it to a safe number. 1 will do. Don't know what that'll do like, but hey ho. Actually, there isn't. It's 0.5. And that's 2. That's, well, it's better at 2, put it that way. It'll work. Anyway. Next, we have the sky colour. Oh yes, uniform. Why am I taking in the sky colour? So that we can make objects disappear into the distance rather than just be cut off or pop in and pop out of range. It's not really needed for the UI, but doesn't matter, we've got it, so we'll use it. Sky colour. May as well take it exactly as it is. Colon, and what we want sky colour as. A Vec3, which is a float 3. Now, the sky colour initializer should be the same as what you set your background colour. And we don't know what that is. So float 3, don't know what it is, I'll put 0.1. Just to make sure it isn't, you know, totally goofy or stupid. There we go, that's float 3. I haven't done any float 4s by accident here, have I? No, that's good news. Okay, what's next? Camera position. As a Vec3. Well, I know that one. That's okay, because we're not using the camera at the moment, are we? So camera position, if that ever changes, we'll notify it, I suppose. But at the moment, oops. It's only asking for its position in space, so float 3. Which is fine. We know what that is. That's a float 3. And we haven't moved it, so where is it? It's at 0.0, comma, 0.0, comma, whoops, comma, 0.0. That's where it is. Next is fog density and fog gradient. And we put those in as constants so they don't go in here. And then out color. Okay. Just wondering whether to put density and gradients in here. I suppose we could. What's wrong with that float? It's having a bad time. It's lost its L. Yeah, I'm putting them in. I don't want to confuse myself. Density equals, and I set it to 0.05. And it's a float. That'll be a double if I don't put that in. That's okay. And the last one is gradient. The gradient fill of fog in 3 dimensions. Is that one? And we'll have 1.5 meters to change the density by 0.05. Yeah, that's about right. 1.5. And again, that's a float, isn't it? Yeah. Those two never change, really. There's no real point. There we go. So we don't need to fill any of that in. That's all filled in ahead of time. We can just change the bits that we want to change. That's the idea of that. So we've got those two numbers are correct. That's correct. Sky colour isn't. That should be background colour. There's a problem I hadn't thought of. We set our background colour in View Controller. So this is going to get absolutely splattered across our code because of the way Swift works. So really, we're just duplicating this one. So what we will be placing in here is... We have to do it direct, don't we? So it's model constants. If we don't do it direct, I found out it doesn't become global. As I found out yesterday. So it's model constants. Huh? Alright. Capitals. Model underscore constants dot sky color this doesn't look right. Can't do that. Stuff it, I won't do it here then. We'll do it in the proper place. So rendering, what do you got? we've got this. How much are we doing down here? Doing quite a bit. That's got to be in the for loop, hasn't it? We don't need to be in the for loop. Oh, yeah, that's a for loop. Right, outside the for loop, we can do stuff. Okay, let's do it then. Light color is set, so we don't need to do that. Self, to remind myself of where things are. Model, constants, dot, sky color equals float 3, open brackets, and I think it was 0. Was it 0.5? One 1 okay. Yeah, we've got a blue background then, haven't we? So 0.1, comma, 0.1, comma, and it's 0.5. Set sky color to your background. Background color or grey for fog. Okay, that's what that's used for, by the way. What else do we have here? Shine, damp and reflectivity was set to values. I don't care about those. That's roughly about it then. So out of all of that lot, oh Seppi, how am I doing today? Absolutely lousy. I'm actually having donuts and coffee as we speak to perk myself up, and I think I've nearly made the decision to go ahead and make this into a game. The UI is so simple for this that I think I might just do it. So at the moment I'm setting the sky colour for the background colour or grey for fog. So what I've got on screen, Seppi, is the C code, which is the version OpenGL version 3.3, GLSL language for the shader, and this is the vertex shader we made in the last series, as you might remember. I think you were around at that time. And what I'm doing is I'm just going to do the light in the wrong shader as usual, because I can, and I love doing it because it really pees off people on the internet. So I'm trying to get faceting. It's a technique to get something called faceting, and if we get it, I'll be able to tell you what faceting is. If we don't get it, oh well, it just means I'm brilliant, and we get very, very fast lighting. So I've got all the lighting constants I want, I think. Let's have a look. There we go. Light, position, color, damper, reflectivity, sky color for the fog, camera position, density and gradient, all doing fog type stuff there. Lovely. That'll do. Do I want to change any more of these? No, the light colour's fine. If you were wondering, by the way, why my blue button went grey, I can answer that quite easily. Oh, I haven't built this today, I can tell. There we go. We put our light at 0.5, 0.5, which is about there-ish. Somewhere in this area. So it's shining out from here. And it looks a bit weird. Well, it should do. Because in here, in our rendering, sorry, if you go down here, we actually set a colour to like a golden orangey colour, and then in our shader we use that colour here. And that's why all our colours are crap. Yeah, clever, huh? Very clever of me. Alright, let's do these again now. Actually, it's got to match. It's got to match exactly, hasn't it? This program's actually now starting to look like a real program. It's just that one class that's bothering me, but it doesn't matter because it's in the rendering. It's in Metal, which I replaced with OpenGL anyway. Load model and load texture are open. I can do the OpenGL counterparts, and the pipeline we just don't need in OpenGL. We do that as we load, so it makes it easier. Seppi, I've got a question for you. In Metal, where is the model held when we load it? Is it held on the CPU side or the GPU side? That's a big question, isn't it? Never used Metal. Good answer. That was a good answer. So what do we got here? We have a float 3. Ah dear. You should use Metal. It's good. It's actually rather good. I've started to research instancing. So we can have many instances of one button. We can have multiple buttons. Yeah. That'd be nice, wouldn't it? Semicolon. Doesn't this look a bit similar, don't you think, with these attribute locations 01 and 2 and attribute locations, layout locations 01 and 2? Don't you think there's something going on here that Apple aren't telling us about Metal? What do you think? What do you think? Can you see any similarities at all? At all? Any similarities? I know I can. It's exactly the bloody same. Ooh, except the way I spell float today. Oh God. Need more coffee. Ah dear. This is the kind of programming I like. I like it because I know what's supposed to happen. Whereas before, yesterday, I really had no ideas what the hell the damn thing was doing. So that really did stump me a bit. It annoys me when that happens because it means that I'm not in control of the computer is in control of me. That's not a good feeling. So I want to talk to you, Seppi, about languages, programming languages, because you were asking about them. Now, programming languages, as you may know, that I discard the programming language completely and just do my own thing, which is what I've done in Swift now. Once I've done that, I can do my own thing and I can program properly, which is the language just gets in the way a little bit. That's all. It's just an inconvenience. And I was trying to think of a way to put it, because a language is just a set of rules to go by. Under the hood, the CPU and Everything else knows nothing about the language. It doesn't care whether you use classes, structs, or whatever. It doesn't care whether you use pointers or not. Well, it does, yeah, on the memory side. It does care about that. Memory management, it does care about. But as for the language and how the language operates, it doesn't give a dingoes. So people sometimes ask me, why don't I use classes? Because the CPU doesn't use classes. You don't see very many classes being done in C or in like assembly language. And there's a bloody good reason why the CPU doesn't do classes. Because it doesn't need them. They are non-functional. The functions within the classes it cares about, but the classes itself, no. That's just metadata. It doesn't do anything. So, my answer to languages in general is, you may want to program in a language, but please note that it's just a set of rules. Or, in my case, I call it a set of guidelines, because I throw the book out the window very quickly and I just can't be bothered with it. I mean, how people manage to write a full program in Swift, I have no idea. I'm not a programmer. But I know how to put a system together that works, so that's what I do. If you have a look now in our object class, everything in here is C. That is a waste of time. But I'll keep it. It's all C. Copy a struct over to something else, assign whatever you want to it, and then insert the data. It's exactly what I've been doing in C. This has come out as a lot neater, which means I'm going to reconvert this back into C for hours. So this code is not really development code. It's come out more as final code, which is a shame really, because I wanted to show how to do that. To get from what we've got to this by extraction of functions. So our light color can now change. Ooh. We've just passed all that data into our shader. Oh no, look at all this data we just passed in. Look what we can do now. Well, we've got a vertex shader. Ooh. I think we'll have to do GUI shaders. Right, so if I take that line out there, and I take that off there, we don't want any of that stuff. We'll leave that light hanging around in case of backwards compatibility. I really should just leave it as it was, shouldn't I? No, I'm not going to. I'll leave light there. But that fragment shader can be like that. The texture fragment shader. That's correct. That's what I want. The texture fragment shader is correct. That's what I want there. So we've got that bit right. This needs to be renamed before I alter it. Otherwise we're going to lose the original. There's only one change that we need to make. Model constants. That's light color. So that's going to come from that instead. Right, what is light colour? Light colour is a float 3. Okay. Our lighting factor is a float. Okay, that's okay. Float 4. Comma 1. 1.0. So we can use our light colour for that. That's fine. This vertex shader. Oh yes, we're not allowed to call the same thing. Thank you. Fog. I'm going to call it a fog vertex shader. So now I've just fixed that. I should have fixed the lighting on here. Yeah, you see it's fixed the lighting now. We've now got blue. So that was a good test, just in case nobody was paying any attention to what I did yesterday. That's just to show you that I made a little bit of a oopsie. Right, so fog, a vertex shader, is the thing I want to make. We have our out position, that's fine. Now we need our lighting factor. Okay. First of all, we need to reorder this because we need a couple of equations out of it. So it's all here. It literally is all here. So model position is a vec4. Position out, yeah, blah, 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 blah. Okay, so that equals whatever we decide at the end. Yes, and this does generate fog, by the way. And you won't be able to see it until you realise that things are disappearing into the distance rather than just popping out and popping in. And I'd advise everybody to get an Apple Mac and try Metal. It will teach you quite a lot about programming. If you want to be a programmer, that is, which I don't. Oh well. So model position is our next value, so let's have that. Model, I'm just going to keep all of the same variables that I used last time. Model position, whoops, don't do that though. That's going to equal something at the end. Okay, let's start at the top. Okay, model position is going to be what, a float 4, did I say? Vec4, yeah. Float 4. All they've done is change the names of things. So float 4. Model position. I'm going to prove to you that this is exactly the same. Equals our model matrix. And that's U. Times a vec4. Actually, we can cut you out now, can't we? That's why I put them on separate lines. Okay. This is how to do lighting the easy way. First of all, never ever do it in the vertex shader. That's your first thing. Always do it in your fragment shader. It looks a lot better. Trust me. Well, that's what they tell you at school. So trust me, that's what they tell you at school. Times a vec4. A float 4, and that is position which is coming in on location layout 0. Vertex in. Dot position. We've got normals. Yay! We might need them somehow. Position, comma, and it's 1.0. That's stupid. Did I not put that coming in as a float 4? I did. No conversion needed. I've already converted it on the way in. You see, if you convert it on the way into a float 4, the 4th position just falls to the default of 1.0 anyway for the homogeneous coordinate. Your graphics card does that for you. Handy hint. Just lie to your graphics card that's how many you're passing in. Expected semicolon. Oh god, yeah, alright. We'll need a delta camera. That's the next line, isn't it? So, float 4 again, okay. Delta camera equals the projection matrix times delta camera. Which we get from where? Oh, sorry, no. Reading the wrong line. View matrix times model position. Okay, that's view matrix, that's that one. That's U times model position, which will come out to 0 because we haven't done it. Model underscore position. There we go. Semicolon. The next one is GL position, which is our vertex out. So that's the last line here. Equals, it should be this one here, projection matrix times delta camera, that is correct. It's just the same as what I had written before, but we split it down and put some variables in there that we can use after the fact. Now we get to the lighting. What do we want? Vec3, okay. And we are going to have our surface normal. I don't understand why they've done this though. If they're rewriting GLSL out for themselves to do this. I really don't get it. Surface normal equals. Why don't I use Vulkan? I do, is the answer. I have a full project of Vulkan in the bedroom on that old computer that I was using. On the potato machine. Got a full project in it, and it's using... What was he using for that? I'm using the community edition of Sea Lion, whatever it's called, for that one. And the language I'm using is Rust for my Vulkan. Doing Vulkan in Rust. That's what I do my evenings when I'm designing different things. I don't take time off. I'm a workaholic. So surface normal equals a float 3. Yay. Float 3. Open brackets. For some reason. Our model matrix times. Our model matrix. Hold on a minute. That's that one there. Copy. Times the vec4 of the normal. Now, has it already changed our normal to a vec4? No, it hasn't, because I bet we've got it coming in as a 3. Thank God for that we have. Because we don't want it to have a 1.0 on the end. For big reasons, normals only are 3-dimensional. They are not 4-dimensional. But we need to be float 4. And it has to be a 0. So it's the normal, which is in our model constants. No, it's in our vertex in. So vertex in dot normal, comma 0.0, yeah, comma 0.0. Do we need an F there? Yes, we do. Or else it becomes a double. Right, so we've got surface normal. Have I changed any of the code yet on this? Or am I just copying this straight out? I don't know. Am I going to have to change any of the code? To light vector. Yeah. I can't type today, so don't worry. And I've gone onto a Microsoft keyboard, which makes it even worse because it curves upwards. The new keyboard I bought is fantastic, but it's now in the bedroom on the potato machine. I might swap it actually. Think about that. Might swap keyboards. Equals. I'll do that tomorrow. Oh, Seppi, do you know how to do mouse picking on 3D? Please say yes. Please tell me you wrote down whatever I told you how to do it. Equals, because I can't remember where the hell I've put my code for it. So I'm going to have to redo it tomorrow. Light position. Light position. Where's light position? Light position is a model constant. Light position minus model position. Okay. And that's float 4. Model position dot xyz. X, Y, Z, semicolon. Oh look, it's exactly the same. What was that? Implicit conversion between what? Where's the float to? I agree. Why is light position a float to? Oh, right. Because we weren't in 3D at the time, were we? We were messing around with the mouse. Damn you. Me messing about with the mouse, making it look cool. Stupid flashy things. It is in a 3-dimensional space now. We've converted it over from our mouse position to inside 3-dimensional space. So that might help. So I did mouse picking in one of my episodes, and I can't remember in which video I did it. So I don't know which piece of code it's in. And I can remember trying to get my head around it at the same time as writing it, because I know how it works. So you just write the formula out, so that's not a problem. But I was trying to get my head around it at the same time. I just hurt in my head. We've got a problem. We're taking it out of user input. That's now a float 3. That'll tell me where it is in the main code. So if I go to rendering now, something shouldn't work. Never mind. It was supposed to break. I'll find it then. Should be up here somewhere at the top. There's the light, and there's the light position equals update. That's self.light.light position. And I'm keeping, damn it, that's a float 2. I was going to keep the code. And it has to stay a float 2. Why am I leaving the light in user input? No idea. Float 3. 0.5, comma, 0.5, comma, 0.0. Okay, that'll satisfy that one. We'll go back to and replace that back. I want this light position to be the mouse one. Oh, not that one. God, this one. Yeah, we'll go back to float 2. Sorry about that, but we'll keep that on the mouse. My bad. And then it's XY. Get it back into screen coordinates. Get it out of OpenGL coordinates. Sorry, metal coordinates. Oops. Pause. X and pause Y. Thank you. Right, let's put those back. So that's back into the right place. Input handler. Set mouse position. We don't actually have one of those. That's a class binding. Okay. That now has a reason to exist. What we're going to be using that for, by the way, is not light position, obviously. It's going to be mouse position. Because that's what it is. We're going to need that for our mouse picking. At the moment we're using it for nothing really, because we're going to be using a different renderer. We need to change renderer. in a minute or two. Have I solved everything to do with that? It's alright, we just changed it back. Didn't we? Yeah. That's how you get rid of it, by the way. I found out you just copy and paste the name. That is bad, actually. But at least I know how to get rid of the damn things now. Shader, how are we doing? Have you stopped complaining? Right, you're going to be using light position from that, which it shouldn't do. Alright, so we now need to take that constant I can't do it. That'll have to go to the fragment shader. You see what I mean? Because we've now got two different values for the same thing. And it's light. Which means that our lighting factor has to go onto this one. The out colour is a float ball. Yeah, that's right. That'll do me. Yeah, I haven't got that. Colour equals colour times lighting factor. Right, let's just forget about that now. This one we're going to sort out ourselves with textures. Expression result unused. Vertex in dot position. Possibly. Our lighting factors and vertex outs aren't going to be like that. So that can go. That can go. We still have the model constants colour. Ah, good. We're down to unused variables now instead of errors. That's good news. So we now got light position correct. We've now got an X, Y, Z. Yeah, good. That's fixed. That's why I kept it in a separate struct for that light variable from the mouse. So, float 3. What do we have? We want a unit normal. Oh, this could be interesting. So, a unit normal. A normalized normal. Which is why I don't call it a normalized normal, because it looks stupid. Unit normal equals, this is going to be funny, normalize. Oh, look. You give out the wrong things. We'll just ignore whatever they've got then. And we'll just type in what I've got. I think that's the best idea with this this game. Normalize. Yeah, strange how that's here. We just want the surface normal, don't we? Surface normal. Done. Oh look, it works. Then we want to float 3. The next one that we've made here, which is 2 camera position. Ooh, sugar. 2 camera position. That's what we made. How do we make it? We took the inverse of the view matrix. The inverse. Oh look. Convertible, huh? Well, let's see if they've done it right or not. Inverse. Yeah, inverse of view matrix. Which is where? There. And they don't have inverse. Oh dear. What are we going to do? What's it called when you invert a matrix? Conjugate? Okay, we haven't got that. There's no conjugate either. Oh dear. Have they buggered up? Or have they not? Alright. So we've actually come to the first sticky moment of today. How do we get the camera position? So let's type in the line as I've got it, which is inverse, which is supposed to be there. Well, it's on the GPU. So why isn't it here? We have the inverse of the view matrix times multiplied by what we got next? A vec4, float 4, open brackets, camera position, which is yes, that's right. Because we're doing the inverse. 0. Oh God, naught. Thank you. F. Jesus. 0.0 F. That was a bit groovy of it. 0.0 F. 1 F to try and get it backwards. We need the dot XYZ of the whole thing. Dot XYZ. We need to minus off that the model position. Dot XYZ, and that gives us a float 4. About to say, no it doesn't. Right, how to inverse a matrix in a metal shader. So metal by example. Well, that metal shader. How to invert a matrix. Shader inverse, float by 4x4 function, unity answers. It said metal. Why have I got a unity? Compute inverse hyperbolic cosine of x. That's not what I asked for. There it is. For the inverse function. Nobody replied to this from Apple. It's interesting, they've got a dirty great big gap in their shader language. Otherwise, yes, we do. Because without it you can't do lighting at all. Oh, we've got a SIMD one, have we? How do I get that then? Yeah, I can load an OBJ model, thank you very much. Lighting. Ambient, don't care. Diffuse. Not overly bothered with, but it does involve an inverse. Specular. That definitely involves an inverse. Can't read any of this. Why can't I read any of this? There's actually stuff going on in the background here. I can't see it. Thank you, browser. Yeah. Materials, yeah. Okay. So is it SIMD in here? Have we got SIMD in here? Yeah, we have. Good. Right. So it's SIMD, I think. SIMD. It'll be 4x4 of some kind. Underscore. Is it going to be 4x4 or whatever? I don't know. I'm lost. It was in the reference pull. SIMD : inverse. Alright, we're in C, aren't we? No, it's not here. Oh yeah, you want the semicolon thingy, don't you? Oh, feck's sake. Unexpected namespace. Sugar. I'm going to have to read this now, aren't I? Hopefully. Just look at the code segments, because... Yeah, you see, that's what I would have said. Float 4 by 4 dot inverse, or underscore inverse. Depending on how they are going to use it. Aspects, yeah, we know about that. Shadows, how do we do shadows? We can't. They've got model, view and projection, yeah. The normal, transpose, SIMD : inverse normal matrix. Okay, so it's SIMD. This is going to be fun. I like things like this. SIMD : transpose. God, did they make a mess of this? SIMD : transpose. Yep, transpose works. SIMD : inverse. I've got an extra. No, VERSE. VERSE, yeah. Doesn't exist. And that's got a semicolon there. Ooh. Alright. So there you go. That's how you do it. And this is the problem with research on the internet. That's what you get told. No member named inverse in namespace metal. So it doesn't exist as inverse. That's the first thing. So it is in the transpositions area. The only other thing it can be is conjugate. And they've got conjunction. Fantastic. So, transpose. What do we got? Matrix, columns and rows. Const device. Well, here's a bugger. I wasn't expecting something like this. What's an impl? Transpose. Implied? Implicit. Okay, I think it's implicit. Arrange encoding. God damn you, Metal. You've just buggered up the whole of lighting. Somehow. Textures. Extractions. SIMD is helper thread. I bet it is. Packing. Anybody got any ideas? Got tessellation, that's fantastic. I'm not seeing anything helpful here. Saturate. Determinant, what we got here? No. Okay, you've got me on this one. The answer that's given in this piece of work is wrong. September 2014 doesn't work. Why is this not dated? '22nd, the 9th, 22nd, 9, 2014. I love research. I've got coffee. I've got donuts left. I've got a little bit of a drink here. Hope everybody else likes research. Oh, look at that. That's pretty. La 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 la. Render pass. Oh, don't introduce the render pass. I just want the goddamn shaders. Oh wow, that's a big shader. So you put that beautiful ball on the front cover and you don't cover it. Potential mathematics, yeah. There you go. This is what we're trying to do, by the way, here. We've got our normal coming straight up. We've got our light, but he's forgotten to put the camera one on. and we've got a camera. So we want to know what comes down here and bounces up to the camera. That's basically it, because angle theta says how much. That we turn that into a percentage. So 90 degrees would be 0, and if you were looking at something directly through the light or something directly at the light, it'd be 1, obviously. Pythagoras theorem, my god, I've never seen that before. Yeah, but how do you invert? How do you conjugate? You can't just put minus matrix, it won't work. You have to invert every single number within the within the matrix. And I know there has to be one. Okay. Colour reflectivity, light source intensity, model view. You see, somebody's been copying my work, I think. What do you think? So they've done a lighting intensity of the normal, the eye coordinate. They have not reversed. They've got no camera. They've put a model view matrix in to cover up the fact they haven't got a camera. Great. Are they hiding it in here? They haven't passed it in, have they? Yeah, KD and LD, that's straight out of the OBJ handbook. A normal matrix. There's no such thing. Don't know where that's come from. There is no normal matrix. A normal is a normal to a surface, not to the world. Unless they're using that for which way's up or something. Alright, let's see if you can reflex something for me. This is going to be interesting. Oh. Okay. But you'll need a few specialized matrix types, and this custom matrix 4x4 data type includes the convenience methods for creating instances of these types. SimDLI, yeah. Find a way to create correlating data types within the view controller. Yes, that's okay. Oh, I could have looked here. One sec, I'm going to check my perspective projection whilst I'm here. Did I get it right? No, I didn't. -2 times far times near over Z range. So I put in far over z range, far minus near. And that is near minus far. So W doesn't look right to me. You still put the -1 in there. Yeah, you do. You did the same as me. So, what do we got? 1 over tan FOV times 0.5. Yeah, okay. The x is y over aspect ratio. Yeah, I agree with that. Z range is far. Oh, far minus near. Okay. Far z minus near. I'm interested. I want to see what happens. I'm like that. Yeah, no. The z scale, far plus near over far minus near. That's correct. They've got it right. So it's the minus. It's a negative. The negative result of far plus near. This is why OpenGL is in the negative plane near z, close brackets, and it's divided by z range, far minus near. Yeah. Okay. And that makes W the one I think we got wrong. And I knew when we looked at it on the internet that I thought it was wrong. It's actually -2 times something. Far times near divided by z range. That's far z times near z divided by z range. That sounds to me a damn sight closer than I got. Right, you just use the scales, you don't use the range. That's correct. So x is what the first position, so that's x, y, z, w. So x is x, y is y, zz is z, zw is -1, and w dot z, the third position, is w. Yes, that's correct. Return. Thank you. Right, we'll carry on now. My apologies, just stop for a bit of maths. Right, it's not sending it in as a uniform by the looks of it. But we're still in Swift here. I'm not seeing anything in here about the reflection. I can see you've got reflectivity, mate, but I can't find your reflections. Why have you got a mem copy in? That's C. You know, this guy's a nutter. Vertex shader. Shouldn't be much in here, because you shouldn't be doing it in here. Alright, so you got a float 3 normalized. Yeah. You're using a dot to get your reflectivity. Yeah, but what about the view matrix? Something doesn't add up here. Where is your camera position? Where is your view matrix? It's hidden in here. Reflectivity times max dot T norm S T norm S normalize. You're not using it. Right, fragment shader. Yeah, you're not using it. You're not reflecting the bloody light. You're just bouncing it. So no, that doesn't actually answer what I asked. Metal shaders color inversion. No, thank you. Okay, we can't do it then. We can't do lighting at this point in time. I don't know how to invert a matrix without the inverse. Well, I do. You do this. But on a 4x4 basis. Yeah, let's have some fun. And then we have to send it in as... But what does it actually come from? So we need an inverse view model view matrix. Metal shader, how to invert the view matrix. Three.js, no. Cronus, no. The Blinfeng shading. Is this back to this thing? Oh, it isn't, right. So this is something different. What date? 6/18. So 4 years later. Here we are. Trying to do our Feng shading. Yeah. Yeah. Okay. Box information. Well, that's very nice of you to put all that information here. No, I want the shaders. Rotation. Actually, have I got the rotations? Oh no, I don't care. Is he using pi? Interesting. Pi over 4. I thought 2 pi radians. No, it's 3, isn't it? Never mind. It's 3 pi radians for a circle. Let normal matrix transpose. There it is. That's why there's a normal matrix. It is the transposition of the model view matrix. So why don't they call it inverse model view matrix? You have to send it in. Okay, we'll have to make one. Why isn't it in the shader language? Clang, 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 clang. Somebody dropped the clanger. So here, we now need a var. I don't believe I'm writing this. Inverse view matrix. And what that equals I wonder if that'd work in the shader language. Probably not. Before I write this a ton of crap, back to the shader. Put up a bracket. We will dot inverse it. Dot inverse. It's in the shade. It's in that language. Dot transpose. Inverse view matrix. We'll have. Right, let's start putting inverse view matrix in, shall we? So, no, this is not quite OpenGL. It's still falling short, is the answer. Float. It's on the graphics card. It's there and it's available. God knows why it isn't there and available here. Because it should be in their library. And it doesn't look as though it is. So in common, we can only set it to a matrix identity float 4x4. Alright, so that's you done. In the shader, we have it, do we? We do. The only thing we've got to do then is set it. Does the view matrix change? No. Where are we setting projection? Inside a for loop. So this can go outside. Inverse view matrix equal our constants. Sorry, model self dot model constants, isn't it? Self dot model constants dot. Now you're saying it's a model view matrix, and it isn't. It's just a view matrix. Something very weird going on here. Dot inverse dot transpose. Okay. Not impressed. Can you tell? Inverse view matrix. Right, we've got it now. So, no crying over spilt milk. Let's get on. That's the workaround. Oh, wait a minute, we better get rid of that. Alright, I've got a bracket left over here. That bracket's wrong. Cannot convert. Oh god, here we go. Cannot convert between vector and non-scalar values. Metal float bar, yeah, and float 3. Vector. You can't do a vector maths. Yes, you can. You just did it there. Model matrix times that. Have I put the wrong thing in here? No, float 4x4. Oh, fuck. Gotcha. What you do is not that. It's got to be a float 4 for matrix multiplication. And that XYZ drops out at the end, not at the beginning. Model position is a float 4, I guess. So it's just the brackets that are wrong. Thank you. I'm brilliant. You wonder how I became a professional researcher? I am not impressed. Right, so we have solved the 2-camera problem, which we need. I can't understand. 1, why is nobody using a camera? Why are they all combining it? Is this why? Are they all combining it because they're afraid of what they're going to find on the other side when they do the shaders? Is that what's going on here? And this normal matrix is popping up, which isn't a normal matrix at all. It's an inverse view matrix. It's your 2-camera looking at things. What we've done there is we have taken the position of the view and reversed it so that we can have the light travel back to the camera. From whichever point we're on, whichever vertex we're on at the moment. I think I know what's going to happen at the end of this. I'm not going to get what I'm asking for. I better get perfect lighting. I'll be damned annoyed if I do. I'm trying to prove that this is a bad idea. And that everybody should do it. You'd never get a degree doing this. They'd probably chuck you out of the course. Saying stop taking the rip. You should see my physics. The answers to the questions on the physics paper. I got a B. I got downgraded from an A to a B because I was correct. I put the real answers down. They weren't happy about it, but I got downgraded for it. Same in chemistry. Never mind. That's life. People don't like it when they are not shown up, but questioned about what they're doing when what they're doing is by the book. You don't like it when you go out, when you throw the book away. Camera position, right, this can get lost for a minute. I'm just going to switch you off. I can't see how. Why have we got this here? Yeah, it doesn't look right, that line. Because that says fragment in there for starters. And that says vertex in for second. Sorry about that, just correcting the cock up I made. Right, we're down to warnings. Unused variable. Well, it's better than we were. Right, what was we after 2 camera position that was, wasn't it? Oh dear. So yeah, this is OpenGL okay, but it's missing a few things. That was 2 camera, wasn't it? So now we need the unit vector to the camera. Alright. From the object, if you're wondering. Vector to camera. And this unit vector is bounced off the object. Yeah. I remember how this goes. That at least some nice drawings on that thingy. I mean, you can sit down and work all this lot out yourself if you want, and it'll just come down to the same thing as what I'm typing, but you might just do it slightly differently. But in the end, you certainly have to do that there at some point. Normalize. Good. We're good. And it's the to_light vector. Unit vector to camera equals normalized to camera position. Thank you. God, I'm going mental. That's correct. Next. That's the unit vector to camera. Now we need a light direction from the object. That's right, and then we can do Phong. These are the variables you need for the Phong equation. I know there's a lot of them, but it needs the lot. So it's just light direction I'm using here. And that should be from the object to the light. Alright, we've got the unit light. Where's our unit light? There. After unit normal. Unit light equals normalized light. Oh, the to_light vector, okay. Right, so we have a vector that goes to the light. from the object to the light. So we have to turn that vector around. And that's all you do, put minus in. So minus unit light vector, yeah. Oh no, take it off. It's not needed. It is really. Yeah, I'll put it on. There's a big reason I want to keep them the same. This has to be portable across 3 different operating systems, so it's got to be the same. If anything changes between them, like inverse view matrix, we're going to have problems. And it means I won't be able to do macOS. And as I've never programmed a Mac before, this could get slightly dodgy. Okay, we're ready. Got unit normals, unit light vectors, cameras, action. Yeah, we've got everything. I think. I hope. We'll soon find out. Alright, let's try and do ambient light. There we go. What have we got for ambient light? Oh, that's nice. That's a nice easy one. Alright, let's do diffuse light. Okay, let's do this one. If it hasn't got dot, we are in trouble. Float, light intensity. I'm not using it anywhere else, are we? A light intensity in this one? Nope. Okay. Is that how we spell it? Alright. Equals dot to something. Yay, we've got it. Thank God for that. The unit normal, comma, and the unit light vector. Those two is correct. Doesn't actually matter which one you use. The brightness of that light matters, and that equals the max, MAX. Yes, we've got max. We're in business. Light intensity and 0, 0. Yeah, we can't have negative. Light intensity and 0.0f. No negatives, please. That's roughly... yeah, we can do the float 3 now. And this will be diffuse light. I've done this a bazillion times, and I should know this by now. It's the brightness. Are we timesing by the light colour? Yeah. Times the model constants, whatever the light colour is, which is why we added it. 0.8, 0.8, 0.8, 1.0. That's the light colour. For this, it's not the true light colour. I'm going to actually alter it and see if it does make a big difference. I think it will. I'm going to put it to sunlight colour, which is different. Interesting. Right, let's have specular. The capital S. I mean, if you've never done this before, it's fine. If you want any of it explaining, can a function which returns a const reference throw? Yes. There's a simple answer to everything like that. Everything can throw. Absolutely everything. The assignment of an integer to an int can throw. Why? Because there's something called overflow. Specular. Oh, the other reason for that is if you try and use a constant of 0.0, what is it, 0.7, the processor cannot recognize 0.7 as it cannot be stored in binary. So that should throw straight away if you are putting a constant to 0.7 float or double. And if you didn't know that, you do now. Right, specular. How much light is directly reflected to the camera? Yeah. Yeah, there's certain numbers that the processor cannot process. There's 0.7, I think it's something like 0.23 or something as well. There's quite a few of them. There's quite a few of them. Which is why when you are doing matrix mathematics on computers, you always start from something called an identity matrix. And you work from that for the calculation. You use that calculation once, and you never use that calculation and add it into another calculation. You start from scratch every time. Otherwise, you will get composite mathematical errors creeping in to whatever you're doing. Gimbal lock is an obvious one, but things will happen in your 3D universe that aren't supposed to happen, like falling through the floor. That's a really good bug. That's a fantastic one. I love the way they do that one. So specular light. We want the reflected light direction. Float 3. Reflected light direction. And that equals reflect. It's in. Now, this is now starting to bother me. We've got dot max reflect normalize, and we don't have inverse. And it's not a hard thing to do, actually, inverse. So I wonder why it's not there. Maybe it was just overlooked. Dunno. Okay, let's reflect. Light direction using the unit normal. So it's light direction using the unit normal for the plane or wherever you are. Okay. Now we need to know the specular factor. This is where it gets complicated. Everything else has been straightforward so far. You can do it in your head, really. This is a dot thingy again. Reflected light direction. And that's with unit vector to camera. How much is coming down the unit vector at the camera? That will give back a value between 0 and a 1. And this is where things start to get awkward, because if it returns a 0.7, like 70%, things can go a bit iffy, shall we say. And it becomes a visual thing if you don't do this each time. That's why I'm putting all of this code into this thing shader. So it does it per vertex and calculates it every single time. If you put it into the fragment shader, then it will do it for every single pixel. That's a lot of calculations. Damn sight more than 3 anyway, for a triangle. So we've got our specular factor. And we have to maximize it, yeah. We have to be careful with our specular factor. Oops, can leave it here, can't I? Specular factor equals the max of specular factor. We don't want it to go below 0. Negative light is a bad place to go. Okay. Now we need the damped factor. Oh God, I forgot about that. Float damped factor equals the damping, which is how rough is the surface of the thing that's reflecting the light. If it's metal, it reflects it like a laser. If it's very, very dull surface, like my desktop here is a dull grey type thingy, mottled grey, it doesn't reflect much light at all. Or it scatters the light, should I say. That's your damping factor. And it's to the power of... Oh my God, we have power. Yay, we have power. Specular factor. To the power of the shine damp. which is held in our model constants. Model constants dot shine damper, which I've already set. Okay. So I think I've set it to plastic or something stupid, knowing me. Hope not. But I set it to pretty rough. Nothing dead shiny. Alright, so finally we can get to the specular light, which is a float 3 after all of that. Specular light equals the damped factor multiplied by the reflectivity the model constants dot reflectivity times light color. Model constants dot light color. And that's your specular light. Done. Not hard at all. Final lighting. Is a VEC4. And I'm going to call it, we're calling it lighting, are we? Yeah, lighting. That's good. It's a good word to call it. Equals a VEC4 made up of the following. God, we're going to clamp the lot, are we? Okay. Clamp. Specular light, comma, 0.01 F to 1.0 F. Now this will actually allow for a whiteout. As if you know how to do the calculations, you'll see that it can go to 3 when 1 is max light. So you can actually get a whiteout from this, because we're going to only clamp them. Not to a third, which you can do, but I wouldn't advise it, because you get very, very dark scenes if you don't do it this way. Diffuse light. 0.01 F as the lowest value and 1.0 F as the highest value. If you do get a lot of whiteout, you can just take these down to 0.8, and sometimes that just, you know, tunes it into whatever style of lighting you are doing, or the design of whatever you're doing. It would affect the mood lighting, maybe. I don't know. Something that I have played with, and I've had some very, very dark, you know, mysterious type of effects because I use fog. Specular diffuse ambient, yeah. Comma 0.0 F, comma 1.0 F. So that's those three added together. And then it is just comma 1.0 F, because we want to see the lighting. Semicolon. Done. That's it. That's your lighting done. There's the out colour, yeah. What we're going to do now is fog. The fogging effect. So we need a float distance to camera. So it depends where you look from, obviously with fog. So we need to know that. And that is just length. See, it's got them all. I don't understand it. Of delta camera XYZ. Okay. Delta camera dot XYZ. Semicolon. Visibility, depending on how much we've decided we want the visibility to be. That's one of the factors we've got control over. Visibility. And that equals the exponent or exponential of a minus power of distance to camera and what else needs to go in here? Times density, which is somewhere or other. Model constants dot, did I call it density? Yes, I did. Density, thank God. And gradient. So that's model, comma, gradient. Model constants dot gradient. There it is. There we go. That's that one. Is that correct? Yeah. So now we just take the visibility and clamp it. Visibility equals the clamp for visibility, and we have to have that from 0. I would actually put 0.01, but that gives you that pop-in thing, so it's 0.00. We go to 0. It's the only time we go to 0 in lighting. 0 is a bad place to try. So that's our visibility. I've put a warning here, maybe we should clamp the final lighting value, or the colour saturation, i.e. blinding light. I'm going to leave it as blinding light. So the out colour, which is here, let's bring you back up now, which is here, becomes the next bit. The out colour is a mix, mix of sky colour, is it commed? Yeah, it is, but we're going to need the sky colour at full. We can actually lower that. I'm going to need some more brackets, because I need that as a vec4. Float 4. Model constant, sky colour, yeah. We're mixing that together with the lighting. I'm mixing that with colour. Whose colour? We're using textures, be very, very careful. with the one that's being passed in, we don't have it. Thank God for that. We've got light colour though. Have we already put the light colour in? We have, haven't we, on that one with the specular lighting and also light colour there. So it's in twice already. No, don't need it again. So it's already included. So it's just lighting. No multiplication there. Good. Makes it better. And visibility. Those three factors should give us our out colour. Oh. That's the Phong lighting shader. Phong Fog Vertex Shader. Exactly how you're not supposed to do it. Come with me, little person. I want to have a word with you. There we go. So on our pipeline, we're going to use that function as our vertex function. Do we have an override on the rendering here? Just in case. Yeah. Okay. Okay, the fragment function didn't like it. Fragment function type is not an MTL function type fragment. What did I do with the fragment shader? I've upset it big time, haven't I? You're getting your fragment shader name from wherever in there. That's fine. What fragment shaders have we now got left? We should have 2 fragment shaders as well. One doing the light. We're using the texture one. Brings the colour in through fragment in. Texture coordinates are given to the sampler. And we've given it a fragment in colour. Yeah, that's right. So which one is it complaining about? fragment, fragment, texture, fragment. These haven't changed. The only things that have changed are these. Oh yes, I did change these. Oh, sugar. Okay, we need a test. On our pipeline. The test is simple. Yee-hoo! There's the test. Why is Fong Vog? I printed out the fragment shader name. Why is that being passed in as a fragment shader? Oh, I cocked up, that's why. Sorry, my bad. It's not a fragment shader at all. Stupid me. It's a vertex shader we wanted to change. And we did, didn't we? Yeah. Sorry, my bad. You should have that one. That'll teach me not to read across a line, won't it? I mean, it does give me a hint here. I don't know. It works. Look, down the sides there. It's gone dark. The normals are working. Oh my God. Wow. Sorry, but wow. We did it. Can you see it though? Can you see the problem? No, you can't, can you? If you put that in the fragment shader, that lighting, what would it do? What image would you get at this point in time? I can see a bit of split there, which is correct. It should split there. That's the faceting I was talking about. There. I think we should take this out of the way so we can see it properly, the faceting. Maybe. Well, hopefully we'll see the faceting better when we put this into a GUI. Oh, I'm so happy. I'm so happy that it's so wrong. And it works. Now, what are the reasons for me trying to do it wrongly? Firstly, the vertex shader runs once per vertex, where the fragment shader runs quite a lot of times for all of... Well, this is just going across like that, isn't it? It's two triangles. So that triangle, the fragment shader, runs for every single one of those pixels to see whether it goes from a fragment and becomes a pixel. Actually, that happens just afterwards. But anyway, in the depth thingy. Have we got our depth buffer working? Oh wow, we can't test it yet, can we? I think we have. I can tell if we have by looking in the view controller. There should be an extra number. Where have we set the screen? We haven't set the screen. No, I don't think our depth is working properly. We might have thrown a stencil in. I've got nothing on the right saying here. Texture, extension, draw, command, right? No, I don't see stencil buffers. No. Vertex bytes, submeshes. No, we haven't got depth buffer, which we don't actually need. So does that mean I've kept those under 1? No, because we've got perspective. So we're not even using a depth buffer. We're using order of draw. Oh my god. So whichever order we draw them in, that's going to be on top. Let's see if we can prove that. Let's see if that is the case. Why did I move it down? Makes more sense actually. Okay. So currently we have the button on top of the monster, but the monster you would think is being drawn first, wouldn't you? Well, it is. But whatever's drawn second goes over the top of it. And that gives us the button above the monster. Button, monster. Button went last. C's on top of monster. Right. Let's try versing it. Actually, I should have just changed the name. I'm stupid. They're both the same, aren't they? Oh, yeah. All I had to do is change the bloody name over. And now the monster is on top of the button. And you can see now that clip is straight across. That's called faceting. It's worse on this side because it's actually running over when it shouldn't. That should come straight up and be in front. So the colour there is wrong. But it's got a reflectiveness on there. So it's actually drawn it the same because we're dead centre. We are dead centre. That's interesting. But you can see that the textures have worked nicely. You can nearly see the stretching of the texture down in there, but never mind. I don't think it has done as bad. Yeah, that works. That lighting's fine. We have to move the light, don't we, as the next test. It's there somewhere. So that's half meter up. Normally I would put it about 2.2. So let's put it about 2.2. So that's 2 meters to our right. It's going to be one of those big lights on a stand that they're using camera. 2.5 meters up will do. We'll mix it up a little bit. And in the X direction, sorry, Z direction, I'm just going to bring it back over my shoulder a bit. Behind me, 1 meter behind me. Beautiful. That's worked. The colour change. Bloody hell, it's worked. Where are they positioned? Oh, have to click on that button, don't we? Yeah, they're at the back of the debris. If I take them -1 in the X, could be interesting scene. Oh no, you can actually see the side and it's lit properly. But it's happened. This is what I wanted to see happen. Look at the top to bottom on that. We can just bring it back a smidgen. And hopefully we'll still be able to see it. 0.95. Bring it back 5 centimeters. There. Oh, we've got a little bit of a slice going on as well. But never mind. You can see at the bottom it's dark. And you can see at the top it's light. We've only calculated the light at that position, that position, that position, and that top position there. And it's 2 triangles going up there. How on earth did it calculate the in-between shading? Because we didn't do it. We put it in the vertex shader, not the fragment shader. If you put it in the fragment shader, that's what you get. But we didn't. I want to see about that tear actually. Oh, that's the plane. The button. Trying to poke through because there's no depth buffer. So as you can see, no depth buffer equals splatterage. What do we need for that? A depth stencil? A stencil. I think so. But that is a proof of concept that they are lying to us. They are saying you've got to put it in the vertex fragment shader. You can't put it anywhere else. It's got to go in the fragment shader. It's got to run 1,000,000 times. All of that code 1,000,000 times per model. And I just stuck it in the vertex shader, which doesn't run hard. Well, about 1% usage compared to the fragment shader. And it works perfectly fine. It shouldn't do. So somebody's lying to us somewhere. I was told that after the vertex shader, let's just look at it here. At vertex out here, it then goes into rasterization, which decides where everything goes on screen. All the colours go on the screen. And then the fragment shader decides which fragment is a pixel. So it uses depth buffer or whatever to find which pixel survives, basically the depth test, which we haven't even put in. And then it becomes a pixel and it's shoved out. At the moment, all pixels are being shoved out by the looks of this. Yeah, they are. Oh dear. Never mind. And it goes on to something else. I think it goes on to the depth stencil after the fragment. So all the fragment does is put the texture on. It then goes to the depth buffer test after this. And that's what Apple told me when I asked. So did they lie to me? Because if they did, there is only one colour and it's interpolating, because we don't put that texture until here. What we're doing is actually we're using the interpolation of the rasterizer, which is an automatic function that this vertex out goes through to here. It used to be fragment shader rasterizer, which is why you had to do it in the fragment shader. Not anymore. And on that note, I'm going to go make myself a cup of coffee because I've earned one. How do I make myself a cup of coffee right here? Thanks, I will do that. It's coffee time. Yay! Do I have a donut or not? Yeah, go on, I'll have a donut. Yeah, now. Now, the worst thing about all of this is that I don't know whether I'm right or wrong about it. Let's have a look. Let's see what I can do. What am I allowed to do in here that's going to give me any kind of ideas of what the hell's going on? In the rendering. Okay. Actually, I want to just see if that works. Oh, it does. But it's now on the wrong data object. Yeah, that's fine. That's okay. It's not an array. Whoopsie daisy. Can't do that then. But I can do that. You can't do it on that one. Put it back to what it was. It's easy doing it that way, and copy and pasting everything. Okay. Oh, I've got the wrong text, you know, have I? Yeah. Oh, it is part of the monster that's goofing then. Or is it? How interesting. Something's not quite right. Yeah. That's what I wanted to see. That's why you need the depth buffer. As you can see, the triangles, they're just being drawn all over the place. You couldn't see when we're looking straight on, but that's why I noticed there was something slightly off. What a fantastic test texture that is. It's rather nice. Right, let's fix it. Keep that scene. We'll fix that scene. How? I don't know. Let's have a look. What will we need? Nothing in there. I'll need the depth testing sandbox stuff because it's a bit weird. OpenGL, it's just say switch it on and do it. In Metal, you get to control the damn thing, like you do in Vulkan. Interesting. But the first thing we need to do is tell the computer that the screen has depth. And I think I put it in the main entry point. There we go. Yeah, it's on the Metal View depth stencil pixel format. There's the piece of code that gives us a 32-bit depth buffer. That creates our depth buffer. Do we need to do anything else in here? Don't think so. It's just a switch we're going to pull. No. Nope, that'll do. So right back at the beginning of the program. First thing that we've got to do. First responder, view did load, blah 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 blah. Anyway, here really will do, won't it? So just stick it after this. There you go. Depth stencil pixel format equals depth 32 float. And our textures are in depth 24. So it's RGB 888. And then there's 8 pixels for the alpha channel. So it's 32. Handy. You can do it as 8-bit, but I don't think we're going to do 8 bits. Oh, it is 8 bits, sorry. 4 bits you can do. Right. Oh. Hello, Muppet. Now, where do we alter? We have to put that line in again somewhere. Where will it be? Got to repeat code. It's Swift after all. So we're looking for metal view, depth stencil pixel format, depth 32 float, somewhere in this code. I think I know where it goes, but there's a depth stencil. Where's your texture sampler? Right, okay. That goes with our texture sampler. We'll have you. Where did we put our texture sampler? In here. Yeah. I'll do it below. So for this depth stencil, I'm just doing a private function. We don't have depth stencil state, it would seem. And it's a variable. There. We'll copy you out and we'll pop you in here. Another variable. So there's enough variables in this to sink the Titanic. That was groovy. We need to call it. So we'll just call it here. Build depth stencil state, whatever device we're using. It's a rendering device I'm using anyway. Don't know what you called yours, but yours is probably just called device. You might have been sensible about it. There we go. So that'll work. Where do we put that extra bit? And it's in the pipeline. Where in the pipeline? Where do we build a pipeline in here? Import, draw, command encoder. Ah, right, we need one for the command encoder as well, don't we? There it is. Command encoder dot set depth stencil state. We'll have you. Command encoder. There we go. We're still missing one line. And I bet it's been spliced off and placed into the scene graph. Primitive. Looks like the right place for it, but I can't see it. Build pipeline state. Pipeline state equals build pipeline state. And it's not in here, is it? The pipeline state will be in the base of this scene. Node, possibly. Yeah, it could be node. No, it's got a bit of rendering in it, but nothing much. Useless class. Primitive node. Instance is what I'm researching at the moment. Game scene. Scene. Do you have our pipeline? No idea. No, it's just a render. Bits of the command encoder. Answers I don't know. Let's see if it'll crash and burn on us then. Yeah. And you're not going to tell me what the error or where the error is. And I know where the error is. It's... oh god. Let's see if I can find it. So it's this line. What it's saying is it doesn't know this bit. And I think it's saying it in here. Here it is. But how do we get it here then? Or who calls it here? It's not Metal View. Is it device? Pipeline descriptor. We tell it the pixel format, but we don't tell it the depth. Who do we use at the bottom? A vertex descriptor. Nope. Je ne comprends pas. Anybody know? I don't really want to have to go through all of these. Instance model. It can't be in floor and cube, surely. That'd be stupid. We're already repeating what we're doing. No, there's nothing in there. Game scene. What have you got? Anything? This is why I don't like scene graphs. When I know there's something wrong and I know what the fix is, and I can't find the reference in my own work because it's just everywhere. That's how you make a scene, by the way. You just add the child. Very, very cute and rubbish. Never mind. Instance, no. There's nothing in there. That's blank. Model. Example draw calls. Model node. So it's either got to be in here or in the node. Well, it's certainly not in the vertex descriptor part, and that's why I was thinking I've just gone to above the vertex descriptor part. So it's where is the rest of the pipeline? So model went to node. It's got to be in node then. Nothing there. And that's the end of that trail of inheritance. There's a protocol as well somewhere in here. This has a pipeline state, MTL render pipeline state, so what's it using it for? MTL device, and that's the inits. What does it do with this pipeline state? What? I don't understand. It has the variable. There you go. Pipeline state equals build pipeline state device. Where is it? Where's that function? Build vertices is done by the model. Build model. Your buffers, yeah. And then it's got an extension. To primitive. Texturable. Texturable will be the protocol. Basically a template for a class. And that will be in metal. You won't know, it won't be in textures, it'll be in rendering. Wrong one. So look at these two anyway. Build pipeline state, yay! Pipeline descriptor, depth attachment, pixel format. There you go. Can't say I told you so. But what the hell is it doing in a renderable extension? God, it's a central part of what we're doing. So you're dead. You just got sacrificed to the gods. Just gonna pop it in here. Pipeline descriptor, depth attachment, pixel format equals dot depth 32 float. Might help. There we go. And it's, as you can see, now we've got the depth. It knows which ones to go on top and which ones don't. So it can actually pick which pixel to show. That actually tells you what the fragment shader is all about. Because the fragment shader is the bit that puts forward each fragment to the depth buffer. And if you've got a proper depth buffer, it'll happen. And look at that, we even got shading inside. We've got corner shading going on, we've got lighting going on, we've got the difference in the colours coming across. It's beautiful. That is fantastic, we found it. So you need it there in your GPU pipeline. You need it there in your view controller here, depth stencil pixel format, so that the main view has a depth equal to the depth buffer that you create. Yeah. So we described the depth buffer there, we made a stencil for that depth buffer, which is what happens after the fragment shader. And we popped it in our command encoder somewhere. Can't remember. There. Set depth stencil state. And that comes off creating a depth stencil, which I haven't talked about yet, where you have a depth stencil descriptor, which is defined for us, and we are going to set the depth comparison function to dot less, which means anything that is closer to the camera will show, which is obvious really. Depth stencil descriptor is depth right enabled. True. So we turn it on. That's equal to GL enable and then open brackets depth test buffer close brackets. That's the same line there. Depth stencil state device.make depth stencil state and create it all, and that gives us our descriptor, and it wraps it in there, and we use that as it's part of the function or class. This is a class, isn't it? God, I hate this. So it's part of the class. It's questionable, which means it doesn't have to exist. And or be used, should I say, not exist, exactly. And yeah, we'll just use that in here. Pop it in here, and there you go. Bob's your uncle got a depth buffer. We can set the depth buffer to do different things in using the stencil state. So it gives us full control. Right, I can move it now without it absolutely blowing up on me. Okay. That's nearly right. That's what I was trying for. It's close. Yep, that's it. Got the edge now. And we have the top light shadowed. Wow. That is so groovy. Oh well, we've now got shading and depth. What a bonus. We got the bonus, yay. What time are we on? Ah. Could do some research on picking. I mean, if I put my... Actually, how do you turn the buttons on? Where are the blooming buttons? Why haven't we got them? And how much aggro is this going to cause me? Key down, key up, mouse moved. What if it comes under key up and key down? I wouldn't have thought so. It doesn't in any other language. Looking at things like Qt. I mean, it's a Boolean. So I expect them to be like button 1 up and button 1 down or something. An NS code. No chat? Okay. God damn it. Yeah. I've no recollection of ever doing Swift mouse buttons. Which probably means I haven't. Are they difficult or something? Is there a problem with Swift and mouse buttons? Is that why it's never come up in the references? Well, there must be a function for them. There's a function for mouse moved. What do you think, Pudding? Sorry, Muppet. You got snot all over you again. Daft cat. Yeah, I'm relaxing. I've been very good. I've done lighting today, like I said I would to all the people. I mean, if they want to switch the video off now and miss me do some research on mouse buttons, that's up to them. But I'm going to take my time and do things properly. I ain't in a rush. It's funny, to me time is not money. Time is just pain. Right, I think I'm set. Monster time. Mouse up, mouse down. Other mouse up. Right mouse up. Other mouse down. Hold on a minute. I bet there's a left mouse up and down. No, there isn't. There's two mice. Right, think about this. They use the Apple laptop, don't they? So on the laptop there'll be a trackpad. Alright, so I'm out of mouses. What about buttons? No, it hasn't mentioned a button at all. Bouton. No, we're out of it. No. We've got up, down. Exited the window. Dragged with the button down. Entered the window. I think that other mouse up might be outside of the window. No. Could be. That could be for actually clicking on the window bars to drag them. There's multiple things on a window. Override function. Mouse down. Okay. What will they do? I have no idea and I've got nothing to look up, so close that. And if you're wondering why I'm not going to the wonderful Apple manual, it's because I've not had any success with it so far. I suppose that's why they call it Swift. Oh, we haven't got a placeholder, have we? My bad. Zero. Nothing on the right. Zero. I have a left click but no right click. Getting 2, so that means it's up and down. I've got a left click. It's a start. Where's the right mouse button? And all the other buttons. So I've got left. Get rid of that a minute. Make sure it's switched off. Can you move, please? That's the keyboard, you dope. This gave us 0 for left mouse button. So did that one. Didn't give us anything else. So there must be more events. I'm screwing on that one. Number of mouse clicks associated with a mouse down or mouse up event. The button number for a mouse event. Ooh. What did I ask for? Button number 0 is all I got. So I've already tried that one. A bit mask identifying the buttons pressed for a tablet event. The system doesn't know what that is. Tablets. Might have to use a button mask. That I understand. Don't care. Ooh. X coordinate change. Ah, delta change. Yes, thank you. We've got the mouse drag. I want that one. Now just try it out. What that should do is give me the X, which is the across coordinate of the drag. It shouldn't give me anything out here at all. But as soon as I come in here, it's not even giving me the drag. It's just giving 0.0. Hold on a minute. It should give me the change. That looks dodgy. Looks very dodgy. Okay. Anything else to send? Yeah, this isn't doing what I'm expecting. I think this is doing it for a tablet. Left mouse down. So it knows. It got the location. Who's doing this? The AppKit subproj NS event. The NS event knows left mouse down. L mouse down. It also knows lock. Button number, pressure, device ID and subtype. The object exception throw. Oh. General core foundation. Handle failure in method. Object file line number description. Yeah, great. Thanks. That was in foundation. Oh dear. We've been just wiping that out and having fun. We haven't got foundation. That's interesting. Every time we make a Swift file, it comes up with import foundation. And we just happily delete it. Oh, but we've got import Cocoa. We should do it. I really want to keep that though, that error. Right, let's look for that event. It knows it, it's got the name. It should have lock. It's got location in window. What does that give? Another crash. L mouse down. It's an NS event type L mouse down. It doesn't give us the command. If NS event.m. Something strange in the world tonight, and we don't know what it is. It's something very weird. That causes an error. NS event. Yeah, that's what we've got. Let's have that. These aren't doing what I think they're doing, which is good. I think they sent back some different way. I got a horrible feeling we need to take the event for the whole mouse, not just mouse up and mouse down. Button mask, what do you do? Just gives me a raw value of 0. Okay, fine. So that does the same as that one. There's something wrong here. There is something massively wrong. Okay. What are we on? Mac OS Swift mouse buttons. It's class var. Variable. Which class, please? You can tell me it's a class variable, but it does help if we know which class it is. One shifted corresponds to the left mouse button. One shifted one corresponds to the right mouse button. So it's the mask. And we're getting 0. Pressed mouse button. It's a variable. It's not here. So it's not in the events. Who has it? Do we have it? Does Metal Kit have it? Override var. Pressed mouse buttons. We don't have it. We are in the NS View controller. Okay. So it's not in the NS View controller. This is stupid. It's not in the Metal View. So who's got it? You're going to tell us who's got it, you little sods? What class? Class var. Class? Whose class? Give us the fecking names of things, you people. Yes, I know it gets all of this, but I don't know who's calling it. See, that returns the NS event. Can I override that one? Associated event mask. That's an NS event. Doesn't look like it. How do you use this manual, please? Can anybody tell me? The NS responder class defines a responder chain. Okay, a list of objects that respond to these events. Clicks a mouse button, taps on it. Yeah. Presses a key. An event is generated and passed up the responder chain in search of an object that can respond to it. Any object that handles the event must inherit from NS responder class. The core AppKit classes, application, window, and view inherit from NS responder. We are in the NS view controller. And we're taking NTK view. Right, I've got NS view here that inherits from NS responder. Keyboard and mouse class NS event. Hold on a minute, we've got NS event. So it's coming through Metal Kit. We don't need that. That's a dove object. We've got NS event. Add you. Hold on a minute, Bob's your uncle. NS event dot. Don't you knit, whatever you do. Class NS event. Woohoo! Overriding the NS responder methods. Oh, well, here we are. Tablet, yeah, AppKit reports all pure tablet events to responder, blah blah blah, tablet point. and tablet proxy. Mouse events can also contain tablet data as event subtypes, so you can handle these events. I don't want a bloody tablet. Yeah, these are bloody tablets. Can also represent tablet pointing and tablet proximity event. Which one do we use, mateys? So you can use tablet point event subtypes if you want to. NS methods tablet, right, point with, yeah. So what I want is I want to override, or I would like an NS event, please, to override it. Alright, so I'm coming down here. Oh, Jesus Christ. NS event was given to us free, wasn't it? Yeah, it's an inheritance. Yeah, I know, love. It's a class. So I think what we're doing wrong here is we're not having the NS event version for mouse up and mouse down. Let's try it with mouse down. NS event. That's the class type. We have the class, so we don't need it. Does that mean we can call it from up here? But that'd be a waste of time. That's view did load. After view did load, we are overriding functions for mouse down. So what can we do with mouse down? Muppet, no. Come on, move. Very nice of you, love, but move. Move, come on. Come on, move. Thank you. Stupid. Duh. Can also represent touch and gesture events. Magnify, pinch, blah, blah, blah. Yeah. With a gesture without overriding the individual touch responder methods defined in NS responder. Right, pressure events. You can create application event monitors that call handlers in block objects for certain event types. Yeah, I don't want to send an event, do I? No. What I've done is correct, it's just said. Key event. Mouse event. Oh! Class func mouse event. Override mouse event with NS event dot event type. Alrighty, let's start this again then, because this is obviously not working. Override func. We should have this function, it says. Mouse event. M-O-U-S-E event. is not here. It is, but not shown. Interesting. And it's with NS event. So with NS event dot event type. Event NS event. Okay. Right. This method does not override any method from its superclass. Well, why don't you try telling that to the manual? With NS event dot event type. So that would be event dot no, it's NS event. Not getting anything. And it does it for me. Yeah, there's something wrong here, isn't there? Okay. Mouse down. It's just given me with event type. Location is an NS point. Modifier class NS, yeah. Timestamp, window number. Context, event number. So that gives us that lot. So which one have we got? Create describing a mouse down or up, moved or dragged event. So we want this one here, mouse event. We get comma location. Doesn't give mouse up or mouse down. Class func mouse event. Alright, so we need that stuff. Okay. NS event dot add local monitoring events for matching installs an event monitor that receives copies of events posted to other applications. Installs an event monitor that receives copies of events posted to this application before they are dispatched. Interesting. Matching dot mouse. Here we go. Left mouse up. Handler. Don't really care. We'll do that from here. Can I convert bar? So we get a event. I'll just copy it. Mouse down. Sorry, left mouse up. Is this what we have to do? Left mouse up. With a event, return a event. Alrighty. Don't think we do it that way. That would be too easy, wouldn't it? There doesn't seem to be much in the way of matching that one. Event type mask dot. We'll do right mouse because that's the one we haven't got or I can't detect. Handler ns event to ns. Why not just self? Cannot convert a view controller to an NS event. Alright. Now where are we up to? Dot self. What is an NS event to NS event query? That's a return value. That's what this is here. Expected type before. It's any. Unresolved. Yeah, okay. Because that's a for loop, isn't it? That's an iteration. It's self dot right mouse down. So that's an A event in with A event. I think this handler bit is this bit here. Alright, they've got me. They've really totally got me on this one. Do they actually give any kind of ideas on how to use this in here or what? This is cobblers. Literally, cobblers. It makes absolutely no sense whatsoever. For some reason, it's not telling us how to do mouse events. Override font. Oh, you're joking me. I really don't believe this is happening to me right now. Okay. Do we need the other bits? Doesn't look like it. Delete. So it's mouse down. And it's override func. Actually, no, you don't, do you? You just type it in and he does it all for you. What have we got here? Right mouse down. That is what I need there. Right mouse drag. Damn you. Damn you, damn you, damn you. So we're going to need that. We're going to need mouse up. We are going to need... This is ridiculous. Right mouse up. We are going to need right mouse dragged. Right mouse dragged. We are also going to need left normal mouse dragged. So why didn't they title it left and right? Okay. Print. Left mouse down. Does anybody feel a slight bit of sarcasm coming into my voice? Oh god, this is supposed to be an easy language. Left mouse up. Left. Left mouse dragged. Right mouse down. Bet you're glad I go through all of this so you don't have to. And dragged. If this doesn't work, we're screwed. What was it whinging at? Mouse moved. What's wrong with that? Why did that go there? Oh. I was trying something out, was I? Thank you. Alrighty, what kind of answers are we going to get on the boards today, folks? Let's have a look. Left click. Right click. Middle click. Middle mouse. Left drag. Right drag. Got it. We're in. We're done. That's our graphical user interface. Sorted. We do need the locations though. We've got the location. Right, so we've been doing it by placing all our mouse into rendering. We have to because that's the only class we've got. Ow. To use it from. It has to go through a class of some kind. We could do it from here, really, I suppose. Yeah, we can. We don't need to go through rendering at all. It's a class. Why am I thinking about classes when I'm programming? Oh, we have an input system. Key state. got the key codes there. Where's the key state? Same. Var left mouse. I'm going to take it out of there. Book of being stupid. Button. Colon. Bool. Sorry. No, it's colon. Ouch. Colon. Bool. It's fine. Is it tea time already? No, it's not. Shut up, pudding. Bool equals false. Var. You can see where this is going now, can't you? Right mouse button. Mouse button. Bool equals false. We don't receive our position, do we? Alright, var left mouse. We'll have to bring the mouse position into here. Well, I'm going to have to destroy that code that we were using, that daft code for the lighting. Drag. Bool equals false. Var right mouse drag. Bool equals false. Alright, we've got the key presses done. Mouse position is coming in through here. Do we set it here or not? Oh well. I'll do that last. Funk. Key pressed. Left. Mouse. Pressed. Ah, yeah, plonk. Don't clash with what they do. Left. Mouse. Why isn't this done for us? Pressed. Why do we have to do all of this? Awkward. We want down colon bool. That's all we need. Down colon bool. And now we just set our left mouse button to whatever that is. We do the same for the right mouse button. She's very, very simple. I think this is better than the one that we've done earlier, but awkward to work out, obviously. Bloody glad we have done though. Yes, Pudding, I'm trying to do this before I feed you. I know. Right. Mouse button pressed. Thunk. Left. Mouse. Drag. This is really awkward, actually. I don't know why we're having to do all of this. It's a bit weird. I mean, you've got a full system here that really does help you out, and then you come across something like this. Never mind. It's obviously not being thought out very well, is it? I'm doing one-liners. I'm doing one-line bloody functions to cope with the stuff that they've done. Right, just copy. And copy the error. That's right. Oh god. Alright, GHT, please. And we want drag. Right, so that sorts out all of that lot. All we have to do in the... This is where we can do this thing, isn't it? Bling. Put that there. Give us the view controller. So all we do is replace print. So we start with done key pressed, mouse down for the left side. That is left mouse pressed. Left mouse pressed. True. And what's that? Mouse up. Left mouse pressed. False. Can you see a pattern? One line overrides. So basically they couldn't write these functions pre-ordered and we could just override them. I wonder why. If I was designing a language, I wouldn't design it like this, with this kind of thing in it. There really isn't an excuse for what I'm seeing. Left mouse drag. True. How do you know when it stops dragging? If, hold on a minute, there must be a trigger off. We can't do that one. That comes in the update. I'm going to have to make that a static shared. for now. Right mouse down. Toru. Right mouse up. What's this? R IGHT underscore. Oh, wait a minute. Might spotted something here. For God's sake, it's just being stupid. Oh no, it isn't. It's just mouse, isn't it? Oh, mouse. MOUSE. Yeah. Alright. You don't need to actually make these functions. I can do it directly from here. I think that's what it's trying to say. I would prefer to make the functions, thank you. I'm not trusting this at all. I don't know what the damn things are called. Right mouse pressed. Bool false. And what's the last one? Alright. Question marks. Right mouse drag. There's a way to do this which doesn't. Yeah. Oh, well. I'm going to set it to true for now. Let's see what happens. I don't know how to not set it to true. A drag event doesn't report its ending, so we might not be able to use those. We might just have to check at the time. That won't work. Right mouse drag won't work. Can't do it. Doesn't work that way. That doesn't work that way. That leaves us with those two, so we can get rid of the drags. They are not going to happen. There's a better way of doing it. Thank you. That one. Okay, I'll just pop you out for a sec. I'm happy with that. I think we can set it from here without that, as that is in open space. But it means that we can't then, well yeah, we can just set it direct. Let's try it. Left mouse button equals true. Yeah, I prefer that. Why does it keep changing every time I click on something? Weird. This looks better. To me, that's direct, there's no lag. Yeah, alright, we'll do it without lag. So that's right. Which one is it? That one. Right mouse button equals true. Yeah. Equals true, false. That looks better to me. Take the garbage out, bin it, and we nearly have a system. After all of that, we should be able to minimize the system to that lot. It doesn't need this lot. Right, that's gone. Key press state. Oh, mouse position, isn't it? The mouse position. I'm going to keep the other one going. Colon. Float to. Equals float to. Doesn't matter what we put there. And mouse position. That's what he's on. Where's it gone? Position equals float to XY. I'll set it there, which takes out that line there. Good. That cleans it up a bit, but we've still got legacy code now in from that. Let's make a silly thing, which I'm not too bothered about. Right, will that build and run? Wow. Starting to look good. Oh, wow, you can see the diagonal there. Oh, yay, look at that diagonal go there. This is what I was trying to find out, why there isn't any clamp to edge. The clamp to edge instruction is on OpenGL and it's on every single motherboard for GPUs, and I can't find it anywhere. That's a very bad edge. And that wasn't created by me. It's there as well. There's one there. So we have to purpose build our models with their own textures, is what that means, to stop that from happening. Which is probably why they haven't put clamp to edge in. You will still see the seam, but it would just be one line. As it is now, it's just a blurred thing which at distance you can't see. So I'm not going to complain about it too much. There's a load of stretching there. There's a load of stretching going on here and here and here. That's interesting. So yeah, purpose-built textures, I think, is the answer to that. It's not their fault. Can't blame that one on them. Right, we've cleaned up that lot. We've now got all the mouse buttons, all the keyboard states. All of this could really go into a structure, you know. I'm not going to be using drag. Decided. Forget it. Don't need it. All I need is that right mouse button being down. And the left click, obviously, to implement something, press a button. So what I'm going to do is a note here. So this is the keyboard key states. Let's have a look what we've got here. Mouse left click for picking items. That's that one. Mouse right click to activate head motion rotation. Okay, and what else we got? Mouse position will just enable us. Mouse position used in calculations. Lovely. Right, so I've got those in now. The function key press. I think I'm going to keep it. Yeah, I'm going to keep it. This means we can start putting all this lot in. That means we can have a camera. That's going to be interesting. It looks like we've got a graphical user interface coming together in 3D. Wow. Oh my god. You see all of this keyboard stuff here, I wanted to put if right mouse button is down. And I can now do it. How long have I got? No, can't do it. Right, tomorrow is the camera. We have it. We have the last part of... Oh my god, that's ace. We have the last part of our puzzle. The camera. So somebody actually answered it properly on Stack Overflow. Thank you, Stack Overflow, for the first time in my life. Literally. We're going to put the camera in tomorrow. Tomorrow we will be able to move our camera, and that's going to present as a problem because that M is a GUI object and should stay exactly where I put it. And it won't, of course. And we have to fix that. Our first GUI object is M. Yes. Fantastic. Good on you, M. Thank you for joining us. That's awesome. Funny as well. Right, and on that note, the cats are being very, very patient, as you can hear. I would like to thank everybody that's popped by for popping by, and I hope I got through that episode without getting too nasty, because I'm not happy with that manual at all. It's not very good. I'm sorry. And I don't want to complain because the language is really good. Swift itself is really good. Breaking it has been pretty hard to do, to be honest with you. That means it's a good language. But you can break out of it, which is just like any other language then, really, to me. So on that note, tomorrow we are definitely going to be making ourselves a 3-dimensional graphical user interface where we can click on buttons. I've got to learn how to click on buttons again. Oh dear. That's okay. I know it's in one of my videos. So take care, and above all, try to have a little bit of fun, a bit more fun than I had today anyway. It's going to get more fun now because I think I've got to the end of the Swift business end of Metal. We're on the last matrix, we're on the last step. After this, it's a doddle. Take care. Have fun.